Hello everybody, today we are doing the next part of part 2 of Unit 2, Modeling Linear and Exponential Equations. So before we've done scatter plots, we have worked with scatter plots with the quadrant count ratio and the correlation coefficient. So what we're doing today is actually figuring out the residual. The residual, you're probably thinking, what is the residual? Well, it's actually very useful in various cases. So you see this, right? Well, this is basically the residual. The residual is how far the point is from the line of best fit. And it's not just it's not absolute value. It's negatives and positives. So, when you see this is a positive, and since this is counting by ones, you can see 1. It's 1, 2, 3, 4. So this is 4 from the actual amount, because it's 4. 8 minus 4 equals 4. But you're probably thinking, how do I get the residual? So you have to get the line of best fit. You get the line of best fit. And then what you do with that is get the actual. You have the actual number, or the actual point, minus the expected point. So it might be greater, that's like 4, and then. So the actual might be greater than expected. So that would equal a positive. But if it's less, if the actual is less, like say 4 and 18, it would be a negative. So there's no absolute value in this, it's just on positive and negative. And that can actually tell a lot, because it can tell you if it's lower than the average, if you're or higher than the average. In some cases, lower is better, but in some cases, lower is not. Such as like time, lower is faster. But today, or for this question, we're doing a cooking competition. A cooking competition rated each participant's disc on both appearance and taste according to a 0.10 scale. An appropriate least square regression line was used to predict a taste rating given from the appearance rating. So, basically what it's telling us is that for the appearance rating, then they taste it. Then they give a taste rating. Okay, so interpret the residual for the dish indicated on the scatter plot above, which is this. So basically, we're trying to figure out what the residual means in the context. We've already figured out it's 4. This number is a positive 4. So, and all of these are 4. So we need to figure out which one is actually representing the residual. This dish actual taste rating was 4 points lower than the predicted based on its appearance. So you can clearly see that this is above so the taste rating, so it's above, so it can't be 4 points lower. So we can cross that out. The dish actual taste rating was 4 points higher than the predicted based on its appearance. So that might be correct, but there's still actual appearance rating with 4 points higher than the predicted based on its taste. So which one is so this can't be correct, because it's basically just an opposite of that. And we know that none of this is lower. None of this is lower. So we know it has to be this one or this one. So the actual taste rate. So we go to D first, because we worked down this time. Now we're working up. This dish's actual appearance rating was 4 points higher than the predicted based on its taste. So this means that it's going right from it. It's like this. 0 to 4. But this is not correct. It's clearly going up and down. Which is, this dish's actual taste rating was 4 points higher than the predicted based on its appearance. So every time, it's basically, the residual is always going up and down. So this dish's actual taste rating was 4 points higher than the predicted based on its appearance. So this is incorrect and this one is correct. So we click this, and it is correct. Now this one is more clustered together as well, and you can see so it has this a strong negative correlation since it's going down. But someone can see definitely that this is this will not continue because if you see this line right here is what's known as it's a certain type of line that allows people to allows you to skip numbers. Kind of like a skipper. Now, I'm sorry for the handwriting, but I'm trying to get this done quickly. So this is basically just a way to say that, oh, I'm skipping numbers and going all the way to a certain amount. So don't blame me. So it says Caden tracked the storage life for bunches of bananas in his store in the storage temperature of the area where he displayed them. An approximately least squared regression line is used to predict the storage life from a given storage. So the regression is just basically how close together they are. Like, really close? It's basically just the line itself. So this one already has its amount. So it's counting by 1. So it's 1, 2. This is 2. So the storage life and storage temperature. So you can so when the storage temperature is higher, the storage life is approximately lower. Well, it's expected to go lower, according to the line of best fit. So this one. So we have to interpret the residual for the bunch indicated on the scatter plot below. This bunch's storage life is 2 Celsius warmer than the predicted based on the storage life. So we already know that if it was increasing or decreasing in storage temperature, it will go like this or this, which is not what's happening. It's going up and down. So it has to do something with storage life. So this is immediately incorrect, and this is immediately incorrect. But we have these to do. This bunch's storage life was 2 more days than predicted. 2 more days. Storage life was 2 more days than predicted based on the storage temperature. This bunch's storage life was 2 fewer days than the predicted based on the storage temperature. So you see that this is 2 fewer because the storage life is days is 8, and this one's 6. So you can obviously see that it's 2 fewer days, making D the correct answer. Now, an insurance actuary tracks the customer's mass and dosage of a certain medicine prescribed to customers. An approximately least squares regression line was used to predict the dosage in milligrams from a given customer mass. Those are really, really small, but we can just make them out. So because these ones are the ones that needed, so let's just outline them. So it says this customer was so we have to make sure it's lower because this one's obviously lower. So higher can immediately be taken out, and this one is greater. Oops. Whoops. This one can immediately be taken out as well. So in insurance, so basically, you can see that the dosage is changing. So the dosage needs to be first. The customer prescribed a dosage 50 millimeters lower than the predicted based on the customer's mass. So, this would obviously be the correct one because the dosage. We're not talking about the mass changing. So these two were the last ones correct, and this one was the correct one. So now you can see that we finished, and I did these four on my own. I did these on my own, so, well, these four. And I just gave you these three for a taste of what's happening. So look at Khan Academy and figure this out, and do something like this. It's called practice, calculating and interpreting residuals. You don't need to have see, I have an account on Khan Academy, but you don't need an account to get this. Or to get this practice. All you need to do is search it up and just type up residuals. And then you can get this type of practice on your own. So, don't feel discouraged if you got an 86 or something lower, because this is just a practice. It's not like it's hurting you in any grades or anything. And plus, even if it's a plus side, you get more points. But don't say that as a reason to lose, because it's just a way that for rewarding perseverance. So make sure that you do this on your own, and you definitely use Khan Academy, because it's a really good website. You may not find everything there, but it's very useful for specific things. And look, it may have a math by grade, but there's a ton of different subjects. As you can see, like high school is very yeah, it's not very explanatory. So you can if you do algebra 1, geometry, and such, you can clearly see which each one is. So that's it. Hit subscribe, smash the subscribe button, and hit the bell, hit the like button, and make sure that you comment on what I can do better and what I can improve on, and just highlight what's good about this is, so that I know not to change it. Bye.